Following on from the last video then, we're going to take a look in this one at, again, the difference between control and deform rig, or rather the advantages of separating the two. As you may recall from the rig anatomies video in the foundations section, you can get a lot of different behaviour if you have a separate control rig and deform rig, mainly in so much as you can just get better deforms out. We saw stuff like this, which is the classic example of deform versus control rigging, where of course we have a single point of pivot rotation for the actual shoulder itself, as in, the skeletal point of rotation. But by having a additional bone that runs across this point of pivot rotation, we're able to get handling for the shoulder, or at least for the shoulder mass of geometry. So we have a 1-point shoulder for animation, but we wind up with a 2-point shoulder for deformation. So that advantage, pretty simple, pretty obvious. However, there are others to this. One of the main ones is that with this deform rig, we are able to have joint to joint to joint as a direct hierarchy. You will remember, I hope, what we pointed out back in the bones videos, that when using things like joint compensation, you cannot have interrupt bones. These methods only work parent to child. So if you have an IK set up where you have the IK plane bone at the top of the arm, you can no longer use joint compensation across the shoulder joint, because that IK plane bone acts as an interrupt. Similarly, even if you have not used IK and you're on FK, but you've put in a little FK offset bone to allow you to get out of gimbal lock easily, that will act as an interrupt in the bone hierarchy, and again prevent you from using the joint compensation options across that point of rotation. Because the deform rig that we have here is targeted over the top of the control rig, none of that happens, and our deform rig is able to go direct, one to the next without any interrupt. So a good part of the way that this whole shoulder setup we have here works is coming from the joint compensation. This is one of the main things that we're using to help get good deformations across this shoulder area, Lightwave's simple skinning system. There are also other advantages when it comes to adding on extra deformation control. Hopefully you'll recall from the morphs parts of the tools how we can try to use morph maps to create additional deformations or shaping as a character or whatnot, moves and poses itself. Well, there were two problems that we saw with that. One, the fact that if you get really, crunched up, over-folded joints, then trying to untangle the vertices with a morph map is essentially impossible. You just can't do it over the top of the bone deformation correctly. However, by having a deform rig that gives us a much smoother deformation in the first instance, what we don't have are horrible mesh overlaps and crunches that need to be fixed with morph maps to the same extent. That's not to say we don't need to use morphs. The point is that we can use morphs far more easily. This shoulder doesn't do anything horrible either when it's, up or down or, pulled round to the front here. It produces very nice clean deformation. If we wanted to put morph maps on top of this to, add in some little muscle creasing, bulging, flexing, the kind of shapes that you get showing through the skin when a muscle tenses, that would be far easier to do and get good results without getting mess along these points of intersection. The elbow here is another great example of this. Of course, we've seen what happens sometimes with elbows or knees, of course, where the inner part, does a collapse when you've only got a single point. But because of the spacer joint that we've got in here, look, you can see that the vertices in between are staying really smooth throughout pretty much the entire rotation of this joint. This inner area, this inside to the joint, is really nice and clean in terms of deformation. So once again, if we're wanting to use morph maps, or perhaps some other kind of deformer, displacement, what have you, to make some adjustments here as his arm flexes and tie that all in, then of course we've got a cleaner initial deformation to work from, which will give us a much more successful outcome. The other thing, of course, you've got when it comes to morphs, and this goes back more to the shoulder than the elbow, is the fact that when we were linking morphs to bones, or if we were going to perhaps use expressions or nodes to link them to some other type of controller, the problem that we get at 3D joints is that we'll often get gimbal flips, we'll get Euler flip. Now either that Euler flip is happening because we've used something like, say, Quat Booster to get us around the problem of gimbal lock, and so our our channels are automatically being flipped for us as we animate. Or perhaps it's something like an IK plane, where not only will the plane item itself flip on heading and bank to maintain its overall orientation, but also the actual full rotation of the joint is then the combination of two bones, the IK plane bone plus the upper arm bone. Once again, when you're just trying to pull channel values and link those to morphs, as soon as a flip happens or movement happens on one bone rather than the other, the morph either doesn't kick in or it comes in at completely the wrong value because it's pulling the wrong value, or rather it's seeing the correct value, it's just that the values have flipped round due to Euler rotations, and so the morph is getting a value that is incorrect for the pose that you're in. By having spacing like this in the Deform rig across the shoulder, what we wind up with is a two-bone system. It needs to flip less. There's no intermediary interrupt bone causing a joint to be a product of two rotations. None of that. The Deform rig is able to string over the top of whatever the control rig is doing. For instance, let's have a look at this joint here. Okay, we can see that it is at 0, 0, 0, and it's pointing to the position of the next one there, which at this base pose here is also at 0, 0, 0. So what I'm going to do is take the main FK arm controller there, and I'm going to twist it 90 degrees. Then I'll come up to its immediate parent, the offset, because this has an FK offset on it to get us out of gimbal lock, and I'll rotate that back negative 90 degrees. Now at the minute, we can see that the values on these things are completely switched around. If we were trying to drive morphs from either of these two controls, then we'd have a problem because we're in base pose, but the morph would be saying, something is twisted here. Of course, because the Deform rig is just going over the top of whatever the control rig does, look, 0 and 0 still. If we were linking morphs to these joints, the morph wouldn't see this double rotation that has gone on here. It would only see the actual shape of the overall pose. What you'll also find is that you can start to create very fine little adjustments in terms of morphs or displacement or whatever else by referencing different things. We just line up with the point there. We can see that this second joint there is closer to the centre of rotation of the control rig than the first joint. What this means is that it will rotate a little bit faster. So of course when we bring the arm up like this, we can see that this joint has turned to 29 point some odd degrees there on heading, whilst this one has only turned to 21. So we could perhaps make any morph adjustments that we wanted to make to this shoulder map come in two parts. We could perhaps have one morph being driven by this joint, say to do something along this edge here, maybe to push the whole shoulder mass up a little bit. And we could have a second morph that referenced this joint, and maybe that morph would be putting some shaping into the skin to show muscle bulging and flexing or whatnot. The result of doing that would be that when our shoulder rotated with its morph adjustment, you wouldn't just be getting this single morph coming on, blending off, blending in, blending out at a singular rate. You would have these two intricate morphs sort of overlapping ever so slightly in strength and in time. Stuff like that can give you really, really natural looking deformation control over your areas of mesh. Just adds more and more visual intricacy. Of course, the Deform rig is bound to little hooks that are built into the control rig, little knobs where the joints hook onto, constrain to. And of course, once you've got your control rig set up, it's very easy to start sort of messing with your Deform rig and getting things in just exactly the right place to give the deform that you want, moving these little hooks, re-resting your bones until the joint itself overall deforms in the way that you need, in a way that looks pleasing. This means that once your rigging process is complete, or at the very least near complete, it's easy to start making fine detail adjustments quickly and easily without having to do large-scale changes to your control rig that then require you to go in and line up your coordinates and values all together, get things rested or pivot recorded just exactly right. Makes tweaking far, far quicker. And of course, there's no reason that you can't do what we've done here, which is to grab these little hooks in the control rig that the skeleton is bound to and sort of shove them around. So as your mesh is being posed and moved, you can grab these parts and shove them around independently of the actual main joint itself to, push your shapes around. This enables an animator to get just the very precise shape and positioning that he wants on the mesh. All of that extremely useful to have. Lastly, it gives you the ability to be a bit freer with the axes when you're working on things. We've talked plenty in the various constraints about how rotations, when calculated in some methods, are prone to an Euler domain, which of course is what causes the flip and this, that and the other. We've seen how we can like to try and get heading acting as the major axis on a given joint or part, how often we might be able to use pitch instead, but also of course certain situations where you're kind of forced into using one because of the kind of design mechanic that you wish to use. So here you can see that the front to back of the top thigh controller there is of course the pitch channel, and that might be fine on the control rig. Maybe once or twice I get an Euler flip or something, but I've got it handled so it all works out overall. But I might not want my deformers doing that. As we can see here, the actual leg joint itself that handles the deformation is on heading forwards to backwards. It doesn't have to match the same orientation that the control rig has because it's just targeting over the top of it. This means you can have different alignments and different orientations on parts between your control rig and your deform rig, allowing you to get things the best way round for each of the two functions. If it's more advantageous to have something oriented one way for control, but for deform it would be better to have it oriented the other by separating the two out, you can do that. There is one thing to be said here when it comes to the idea of separating deform from control rigging. And it's sort of a point of, definition in a way. Here we've got this giraffe character rigged with genoma who we'll be seeing later. And he has all of these controllers that drive the bones in him. The bones here in the neck are clearly the bones deforming the character, but we don't animate them directly. They are using a same as item constraint and pointing themselves to this neck null. In a way, this is a separate control deform rig, or it is from a certain point of view. This null is not a part of the actual, rig hierarchy, so to speak. However, of course, the legs, which are operating in here on IK, the goal null setup and the poles and everything else for the legs is again external to the actual rig hierarchy, but the bones themselves are using targeting and IK and so on and so forth to reference these goal items and whatnot. So they're kind of the control bones and the deform bones. As such, as I say, there's very much a point of view thing to be taken into account here, and separating control structures from deform structures isn't a totally black and white thing. It's not either all done in the rig nor all separated out in its entirety. You can sort of, dice things up in a half and half type of way. And so with that pretty much brings us to the end of the tools section here. As I said in the last video, I hope that in light of having seen all of the different tools that are available to us in Lightwave and the specifics of how they work, many of these ideas of rig design and the different ways that you can construct an entire rig, this control deform separation, and all of that should, I hope, be starting to make a bit more sense to you, and you might be starting to get various ideas about different ways of doing a number of things. So from here, the next section will of course be the practical and project section, where we will see plenty of examples of different ways of stitching things together for different kinds of rigs, different kinds of setups and different kinds of needs. So let's wrap this one up and move along there.